During the mid-19th century, Europe witnessed the widespread collapse of suspension bridges due to the fraying of industrial cables during turbulent weather, causing them to snap under the weight of their decks. When German-American engineer John Roebling proposed constructing the largest and most expensive suspension bridge over New York's East River, city officials understandably expressed skepticism. However, with Manhattan facing increasing overcrowding and river congestion from Brooklyn commuters, the government approved Roebling's proposal in February of 1867. To address the shortcomings of European bridges, Roebling devised a hybrid bridge model, incorporating elements from both suspension and cable-stayed bridges. Large cables, supported by central pillars and anchored at each bank, were integrated into the design, ideal for supporting long decks hung from smaller vertical cables. Drawing inspiration from cable-stayed bridges, Roebling added diagonal cables running directly to support towers, enhancing the bridge's stability and reducing the weight on its anchor cables. While similar designs had been employed in other bridges, Roebling's plan here surpassed them all in scope. The new bridge featured a deck spanning over 480 meters, 1.5 times longer than any previously built suspension bridge. Given the deck's substantial weight, Roebling's proposal called for over 5,600 kilometers of metal wire to create the bridge's cables, as standard hemp rope would not withstand the load of 14,680 tons. To support this weight, the towers had to stand over 90 meters above sea level, making them the tallest structures in the Western Hemisphere. Despite Roebling's confidence in his design, tragedy struck in 1869 when an incoming boat crushed his foot against the dock, leading to his death from tetanus within a month. Fortunately, John Roebling's son, Washington, a trained engineer, assumed his father's role. The following year marked the commencement of construction on the tower foundations, the most challenging step in building on the rocky riverbed, involving the use of several pneumatic caissons. Workers lowered these airtight wooden boxes into the river, where a system of pipes pumped pressurized air in and water out. Once established, airlocks allowed workers to enter the chamber and excavate the river bottom. They placed layers of stone on top of the caisson as they dug. When it finally hit the bedrock, they filled it with concrete, becoming the tower's permanent foundation. Workers faced dismal and dangerous conditions in the caissons, lit only by candles and gas lamps, with chambers catching fire several times. Another threat was the bends, a mysterious ailment at the time, which we now understand as decompression sickness. In 1872, it nearly claimed the life of the chief engineer, leaving Washington paralyzed and bedridden. Undeterred, the Roeblings pressed on, with Emily, Washington's wife, managing day-to-day project communications and operations. The bridge encountered further troubles, with construction over budget and behind schedule by 1877. Compounding the issues, the bridge's cable contractor had supplied faulty wires. Fortunately, Roebling's design included abundant fail-safes. After reinforcing the cables with additional wires, they suspended the deck piece by piece. It took 14 years, the modern equivalent of over $400 million, and the combined efforts of 3 Roeblings. But when the Brooklyn Bridge finally opened on May 24, 1883, its undeniable splendor endured. Today, the Brooklyn Bridge stands atop its antique caissons, supporting Gothic towers and intersecting cables that frame a timeless gateway to New York City.